Moving on to the next part, which has to do with the dissociation constants. Dissociation. Constants of your acids and bases, which essentially your dissociation constants for an acid is going to be Ka, and for a base, it's going to be Kb. Which, to keep in mind here, it's that Ka, Kb, okay. So Ka just means that the larger it is, the larger equals stronger acid. And with Kb, same thing. The larger the value is the stronger the base. So Ka is for acid, and then Kb, B is for base. There's no trick here. So yeah, but then with Ka and Kb, only weak acids and bases have Ka values, or Kb values. So yeah, so it's like I said previously when it came to strong acids and bases that they dissociated fully. So what you started with is what you ended with. With weak acids and bases, your Kas and Kbs are kind of there because you didn't dissociate fully. You dissociated by this much every time, essentially. But it's like any other K expression where Ka is equal to your products over reactants. And it's the same thing for Kb. It's products over reactants. So take for instance if I were to give you the weak acid of acetic acid, which is Chaku, as I've said like a billion times, I'm so sorry. This is a liquid. The rest of these things are aqueous. I keep forgetting to write them down. So you're going to end up with CH3COO minus plus your hydronium ion. So this right here tells you that it's an acid, or that you started off with an acid even if you didn't know it was acetic acid. So then you're going to have a Ka. So then to write the Ka expression, I would just write the acetate ion times the hydronium ion all over acetic acid. Oh my god, there's a mosquito in my room, so if you guys hear a random clap in the middle of this, it's going to be that. So yeah, so then take for instance now if I were to give you ammonia, which is NH3 plus water, it's a liquid, it gives me NH4 plus OH minus, and this OH tells me that it's a base, so we're going to be using Kb. So then Kb is equal to NH4 plus times OH minus all over NH3. Parentheses on that. So yeah, that's it for when you're writing the expressions. It's just products over reactants. You just have to keep in mind, if it's an acid, it's Ka. If it's a base, it's Kb. So let me erase all of this. And I'm going to leave that to the side for now. So then, like I say, almost every week in lecture, it's that everything in chemistry is kind of related. So Ka and Kb are going to have a relationship. And essentially what that relationship is your Kw, which if you guys remember from the first video of this, or what I'm hoping you guys watched as the first video, is your Kw, which is 1 times 10 to the negative 14. Well, your Ka times Kb gives you your Kw. So if ever you're given a Ka for something that's basic, then you would just do Kw divided by Ka to give you Kb. Right? So yeah, that's not too bad. But then, so let's just take, for example, the acetic acid. It has a Ka of 1.8 times 10 to the negative 5. So if I wanted to find the Kb, all I would do would be 1 times 10 to the negative 14 divided by 1.8 times 10 to the negative 5, and that should give me 5.56 times 10 to the negative 10. And that would be our Kb. So yeah, it's just the relationship between them where Ka times Kb gives me Kw, and I can use one to find the other. Oh my god, this stupid mosquito. So yeah. So then with your weak acids and weak bases, you have this other thing called your pKa and your pKb, which if it sounds kind of like, I don't want to say, well yeah, familiar, it's because it's like your pH and your pOH. As in, to find pKa, you do your negative log Ka, and to find pKb, you have your negative log of Kb, and your pKa plus pKb gives you 14. So it's a lot like pH, it's just that in this case, you're dealing with your dissociation constants as opposed to the actual concentration of hydrogen and oxygen. And so, let me just put this here. Kb. The smaller the value of them, stronger the acid or base. So it's kind of the opposite of your Ka, Kb, whereas with your Ka and Kb, the larger they were, the stronger your acid and base. But with pKa, it's the smaller they are, the stronger your acid or base. Right. So then, let me erase this. So let's do a practice with hypochlorous acid, which is HClO, and it tells me that it has a Ka of 3.5 times 10 to the negative 8. So what I want to find is my pKa, my Kb, and my pKb. That's a question mark, not a 2. Right. So there's 2 ways to do this problem, and I'm going to show you guys the 2 ways. So one way is that we find our pKa first, which is pKa is our negative log of our Ka, which in this case is 3.5 times 10 to the negative 8, which gives me a pKa of about 7.46. So there's one of our problems solved. So then the next step is that I would find my pKb by simply doing 14 minus 7.46, right? Which would give me a pKb of 6.54. That's a 6, I promise. Right? So then the next thing that we would do, which I think is the easiest way, which is why I did it this way, is to find my Kb. I kind of do what I did when we would find our H concentration from pH. So to the negative pKb, which would be 10 to the negative 6.54, which gives me 2.88 times 10 to the negative 7. And that's our Kb. So this is one way of doing it. And another way of doing it would be that we would solve for our Kb first by doing our Kw divided by Ka, which would be 1 times 10 to the negative 14 all over our Ka, which is 3.5 times 10 to the negative 8, which would then give you 2.87 times 10 to the negative 7, which are off by a couple of decimals, but it just has to do with the rounding and so forth of things. Yeah, so then that would be our Kb. And then we find our pKa by doing the same thing as before, which would then give us the 7.46. Just going to put a Ka. And then you would find pKb, just same as before also, 14 minus 7.46, which gives you 6.54. So yeah, that's two ways of solving it, honestly, so this would be the other way. So I think this way is just easier because you save yourself the hassle of having to divide things. But there are times where you do have to find your Kb by doing this because it doesn't, pKa and pKb don't matter, so that would be extra steps in your problem and you don't want to do that. So yeah, so this is the way to do it if you're just trying to find your Kb from your Ka, and this would be the way I would, and this way would be the way I'd do it if I had to find all three things from one given, just because I think it's less steps. So yeah, that's pretty much it for the Ka, Kb, and how they're related to each other. Next video, we're going to be doing ice tables when finding pH from our Kas.